talk about logical operations and truth tables. Now, logical operators are operators that are used to combine comparisons together into more complex logical comparisons. So, for example, we've been using comparisons of the less than or equal to or not equals or equals. What if we want to change some of those in a kind of logical type of way? Well, that's what our logical operators are for. Now, there's three different types of logical operators in Python. There's the and, the or the not. So and will evaluate true if variables p and q are both true. Otherwise, they're false. Or will evaluate false if p and q are both false. Otherwise, everything will be true. And then finally, not evaluates true if p is false and vice versa, or which means that if false, it will evaluate as true. Now let's talk a little bit about a truth table. A truth table is used to evaluate all combinations of values and the results for a logical operator. These are used all the time, especially for electrical engineers. But the three, and they use them all the time for like NAND gates, NOR gates, OR gates, AND gates, all of those. We're going to use them here to kind of give you a better understanding of what this looks like. So let's look at a truth table for the AND operator. And first off, let's talk a little bit more actually about the AND operator. When P and Q are both evaluated to be true, then the result is going to be true. Otherwise, it's going to be false. Here's a real-world example. A mammal is a warm-blooded animal, and it nourishes its young with the milk. That means that platypuses, even though they lay eggs, are considered mammals. So here we have a situation where we have one condition. Is a mammal warm-blooded? Yes. Does it nourish its young with milk? Yes. Combine those two together, and that means that it's a mammal. So let's look at the truth table here. Now we have a value of P and a value of Q. P is the statement on the left of and Q would be on the statement on the right. So if both sides are true, then the evaluation is going to be true. Now if P is true and Q is false, that means it's going to be false because they're both not true. And the same thing with P and Q being reversed, where P is false and Q is true. That's still going to evaluate as false. Now, obviously, if both are false, then the evaluation is false. Okay, let's look at the OR operator. Now, when P and Q are both evaluated as false, then the result is going to be false. Otherwise, it's true. Actually, this is wrong. If P and Q are both evaluated as false, then the result... Oh, sorry, yes. If this is false, otherwise they're always true. This is commonly mistaken for the English use of or. So, for example, I will stay or I will go. You can either stay or you can go, but you can't do both. Now, the computational or means that if you can both stay and go, they're still true. So think of it like this. Do you want a ham or turkey sandwich? Or do you want both? Those conditions are both allowable. Here's a funny XKCD related to the statement. He's asking, "I'll be in your city tomorrow if you want to hang out," and then he says, "But where will you be if I don't want to hang out?" If I just remembered I'm busy, and that's why he tries not to be pedantic about conditionals. So let's look a little bit more at the truth table for the OR operator. Here's the truth table. If P and Q are both true, then the evaluation is going to be true. Now, if P is true and Q is false, this is still going to evaluate as true. If P is false and Q is true, then they're going to evaluate as true. And then finally, if P and Q are false, then it will evaluate false. So the only time that the OR operator evaluates to false if both the right and left hand side of its operator is false. Now let's talk about the not operator. This basically reverses the current bool to its opposite. So for example, going back to our go stay, this means if we're not going, that means we're staying. Or if we're not staying, that means that we're going. Let's look at its truth table. It's very simple. You only have one side to it. It is not and then the value. So not P means if it's true, it'll be false. and not p of a false value means it'll be true. Let's look at some examples of our conditionals here, or logical operators here. So going back to my scratch pad that I have here, let's set a value for a equal to 10. Let's check to see, let's say we have a situation where we want to check to see if a is in between whoops, can't spell today, 0 and 10. How would we do that? Well, if 0 is between 0 and 10, that means that a needs to be greater than or equal to 0. Oh, actually, you know what? We don't want it to be inclusive. So let's say it's not 0 and it's not 10, but it needs to be in between. So a needs to be greater than 0 and a needs to be less than 10. Let's see how this evaluates. And I'm actually going to print this out right here so that we can see its results. And there we go. This evaluates to false. And that's, oh, sorry. Let's say we want to check it. And that's actually correct. That's the way we would want it to be, because we want to see if it's between 0 and 10, not including 0 and 10. So in this situation, this won't work. To make this work, we're going to do equals, and then that includes that in there. So let's see what this does. And that evaluates to true. Now let's change this to 20. Back to here. Is 10 in between 0 and 20? Well, let's check. It is, and that's that situation. So now let's do another situation. Let's check to see, let's say I've got A and B. A is equal to 10 and B is equal to 5. Let's check to see if A and B are divisible by 2. When we look at this, this shouldn't be the case because B is not divisible by 2. Let's check this out and see how this works. So remember, this operator checks is the remainder operator. So we're going to check to see if 10 remainder 2 is equal to 0. That means it's evenly divisible. That means it's divisible by that, that value evenly. And so we're going to do that. And B percent 2 is equal to 0. Okay. We're going to wrap a print statement around this. Let's run this. And this is false because B is not evenly divisible by 5. So let's change this. Oh, you know what? Actually, let's keep this the same, but let's change this. Now, is A or B? Let's see what that brings up. And that is true because A is evenly divisible, even though B isn't, A is, and this condition will evaluate to true. Let's move on to the next one. Now let's check if A is divisible by 2 and B isn't. So how do we do that? Well, first we need to do an and in between here. And then we're going to do not B less than or equal to, or sorry, B divisible by 2. Let's check this and see what this does. And that evaluates to true because A is divisible, evenly divisible, and B is not evenly divisible. Okay, now I need to talk to you about order of precedence. Order of precedence is similar to like what we have in mathematical order of operations. This means that there is an order to which logical operators are going to be evaluated. So we have the less than, or equal to, equalities. Not equals is not included in here, but that's the same in this. greater than or equal to, or greater than. Those will all be executed before not, and ors. So all of those are going to be executed first. Then a not will be executed, then ands will be executed, and then ors will be executed. So let's jump back to our example here. And I'm actually going to jump into the IPython terminal again. And let's evaluate this statement. So this we would expect to equal to true, correct? Well, what happens? Actually, we get an error. And the reason why is because we do an evaluation of the not first. So that's actually happening first. And so this causes some confusion. So we need to make sure that when we start doing complex logical operations, we need to wrap parentheses around that. So this is actually going to evaluate the not true first. And the reason why, so let's look back at this a little bit again. So false double equals not. This is what's getting evaluated first, because the equality operator has a higher order of precedence. But this doesn't make sense because false does not equal not. That's an invalid syntax. That does not make sense in Python. This makes sense. So we need to run this guy first before we run this guy. So we do that by wrapping the parentheses around there. And now we get our result. So be sure to always evaluate, or be sure that when you're evaluating statements, to make them the way that you intend to evaluate them, and to be clear to wrap parentheses around them. That'll make your life a whole lot easier. Now let's talk about short circuit evaluations. Now Python does what's called short circuiting evaluations of logical operators. What this means is that it's going to evaluate a statement until a true condition is met or it's reached the end of the statement. That means that some operators may be actually skipped in the statement, which can lead to some unusual behavior that you may not be expecting. Let's look at that and see what that does. Let's go back to our situation. Let's say A is equal to 0 or to 10 and B is equal to 2. Now, take the statement of A is greater than or equal to 0 and A divided by B is greater than 0. So what we're doing here is I want to make sure, is A positive? And if so, is A divided by B also positive? And let's see what that does. So we'll wrap a print statement around this. And we'll run this file and let's see what happens. This evaluates to true. And this does make sense. 10 is greater than 0. And 10 divided by 2, which is 5, is also greater than 0. Now, what happens if we set B equal to 0? Well, you should be thinking to your mind, but wait, 10 cannot be divided by 0. That is undefined. And you'd be correct. This is going to raise a 0 division error, right? Let's see. Yes, it does. And that's exactly what we would expect it to do. Because 10 divided by 0 it's not defined. And so we get a 0 division error. And that's exactly what we would expect it to be. Here's another thought. What if we set A to negative 10? What will this do? Well, would you expect a 0 division error? Because negative 10 divided by 0 doesn't matter. It's still going to be negative 10 divided by 0. Anything divided by 0 is not defined. It should raise an error. right? Let's see. No, it doesn't. False. And here's the reason why. Python evaluates a greater than or equal to 0, and since a is negative 10, this statement is false. So because this statement is false, this entire statement, the logical operator, is now false. It's going to stop there. There's no need to proceed forward in the operations. And that means it's going to evaluate to false. So be careful when you start doing some of your logical operators. You might run into a situation like this where there's an error, and you may not catch it until B is actually set to 0 and you get that error. So be careful of those types of situations and how they work. Now, we've gone over logical operators and truth tables. In the next video, we're going to talk about some in-class assignments that you can do to work on in practicing the logical operations and truth tables.